Hi everybody, welcome to the new unit. Today we're going to be focusing on polynomials, more specifically about exponent rules and then polynomial operations. So this first video is going to be mainly focused on the exponent rules, which hopefully will seem familiar to you. There are quite a few of them, so make sure you write each example down, and if you have questions, make sure you let me know in class. So the first rule we're going to be talking about with exponents is called our product of powers. And what this means is that you have two polynomials with an exponent, so for example x squared times x to the fifth, and if I'm multiplying them, the two terms together, then I'm going to add my exponents. So x squared times x to the fifth would be the same as x to the 2 plus 5, which is x to the 7th. Okay, so product of powers, so multiplying two things with exponents. Okay, and this would work for anything, so we could say y to the 8th times y to the 5th, and we could add those exponents together, and we get y to the 13th. Same concept with the quotient of powers, except this time we're doing division. So for example, we might have x to the 11th divided by x to the 5th, and when we are doing division, we subtract our exponents. So that would be the same as having x to the 11 minus 5. So this would be x to the 6th. Okay. So when you multiply, that's the adding. When you divide, that's the subtracting. Okay. And the key here is that the bases are the same. So that it only works when the bases are the same. Next rule is when we have negative exponents, and this is a really important property. Negative exponents would look something like this. If I have x to the negative 5th, we never want to leave exponents negative. So instead what we do is we flip it and make it positive. So I'm going to flip this whole thing. So I'm going to have 1 over x to the positive 5th. So notice that I took all of this and I made it into a fraction, and then I made my exponent positive. Okay, so let's try another one. I might have, let's see, 3x to the negative 3rd, and I'm going to flip the part that has the negative exponent. So this would become 3 divided by x to the positive 3rd. Notice that the 3 is not with the exponent, so it stays on the top. Only the part that has the negative exponent is going to flip. Okay, and anytime you change it from either the top to the bottom or bottom to top, then the exponent is going to change signs. So you should always end up with a positive exponent. A power to a power, or power of a power, would look like this. If I had x to the 2nd all to the 4th power, when you have a power raised to another power, you are going to multiply the exponents. So 2 times 4 would be x to the 8th. Okay, so notice that the original one, you're multiplying the bases together. Here, you would be dealing with a power raised to another power. Okay, so you multiply the exponents. So that might also look like something like this. Maybe I have d to the 5th all to the 6th power, so that would be the same as d to the 30th. Okay. We have 3 more left. Power of a product, that's going to look something like this. I might have 2 things in parentheses, for example, a times b, all to the 5th power. So what this tells us is we're actually going to be distributing our exponent, because each of these variables has a power of 1. So what I'm going to do is take 5 times both of them. So this is going to be the same as a to the 5th times b to the 5th. Okay. And this would work for any variables or numbers. For example, I could also have x to the 6th times y to the 3rd, all raised to the 2nd power. So if I distribute my power, I'm going to get x to the 12th times y to the 6th. So you want to make sure you take care of everything that's in the exponent, or in the parentheses, and distribute completely. Power of a quotient is similar, but now we're dealing with division. So we'd have x divided by y all to the 3rd power. Same thing, distribute to each part. That's the same as x to the 3rd divided by y to the 3rd. Okay. And lastly, the 0 power just says x to the 0 power will always be equal to 1. So anytime the exponent is 0, your answer is always 1. So that should be really quick. 8 to the 0 automatically equal 1. Let's go ahead and go through an example using all of these different properties. I'm going to give you an expression and I want us to simplify. We've got 2a to the negative 2 times 3a to the third b squared, and then times c to the negative 2. So here I'm going to be multiplying everything together. So I'm going to multiply things that are like terms. For example, 2 times 3 would get us 6. I'm going to multiply those. Then I can multiply all the a's together. So we have a to the negative 2 times a to the third. So if I multiply those, remember when we multiply, we add the exponents. So negative 2 plus 3 is going to get us a to the positive 1. And then the last part, look for any b's. Well, there's only one, so we're going to leave it as b squared. And then lastly, our c value, so that's going to be c to the negative second. Now remember that we said in our rules we can't have any negative exponents. And the only negative exponent I have here is the c. So what I'm going to do is move the c value down to the denominator. So everything else is going to stay where it is. And this will give us 6a to the first, b to the second. And then all of that is going to be divided by c to the positive 2. So I moved c down to my denominator and made my exponent positive. And that would be our final answer. Okay, so if you have any questions about the rules we used here, let me know. That uses the multiplication as well as the negative exponent rule. We can try one more, or you could try this one on your own. If I give you 15 c to the fifth d to the third divided by negative 3c squared d to the seventh. So if I would ask you to simplify, remember the things that are in common go together. So the 15 and negative 3 you can divide, the c's you can divide, and then the d values you can divide as well, and then reduce. So if you try that on your own and have me check it in class, I'd be glad to look at that. That's it for the exponent rules.